Hey folks, today we are trying to understand the CRT 5000 infrared reflective sensor. You may have encountered this in two different forms. Typically, line following robots come with one of these tri channel, um, uh, which has three sensors. If you notice the left, right, and middle, or you might have seen a standalone. Um, Higher reflector sensors. So the goal of this video is to understand with least amount of code and also understand the different applications and behaviors it demonstrates and how it works. Quick theory behind it. Um, it has two components. Um, if you notice, there are two lights or light-looking things or LED looking things. One of them continuously sends out IR beam or infrared light. The other one reflects back and it kind of measures what is the loss, how much reflection is back, and try to create a runway for a line tracking robot with a paper and a black um, electrical tape just to demonstrate this one. Things you need for this is Uh, an Arduino board, clone is what I'm using, USB connection, Arduino IDE, three jumper cables. If you have color, that would be preferable so that you know which one is voltage, 5 volts, which one is ground, and which one is signal, as it requires three, if you notice in this specific one. The other one has two more because it just has left right, if you notice that. All right, so you see there is a S and a V plus and a G. Let me turn it on. It's got at the bottom of that S, V plus voltage, and G on the leftmost side. All right, so to start with, you need a Arduino Euro board. This is a clone um, that came with a robotic car. You have red jumper cable collector connected to 5, ground is connected on a black jumper cable or wire, and the orange one is the one which we will be reading as signal. Um, this IR detector sensor is essentially a existence of a an object. Object detection is what works, and we'll figure out the range and few other behaviors practically. Uh, all I do is I connect ground, voltage, and my signal, which is connected to analog 0 A0. All right, it's lighting up, and it's so now if you notice the light turns on when it detects some object. Let's keep the my hypothetical runway for this robot or drone or whatever, and as you can see, it is already doing it because it's running the code that's displayed. Let's go to code, let's upload. Okay, this is successfully uploaded. Let's open the serial monitor, and this delay is added just to make it human readable, otherwise it goes way too fast. So as you can see, it's reading a value of 20. Even if you don't have an idea of like how it is behaving, you can experimentally figure it out. When it's on the black electrical tape, it's reflecting less infrared light back, so it's reading higher loss. When it switches over to white part of the paper, it reads the loss value lower. So what we are figuring out is lower the value, it is detecting object. Higher the value, it kind of is losing the infrared. There's no reflection back from the specific object in front of it, or there is nothing in front. So typically this, just for demo purposes, if you notice, even though there is white paper in front of it, it's still recording higher values or higher loss. The reason for that is the range of this sensor is 1 to 25 millimeter. So just to demonstrate, if you look at scale, it's sitting right at 25 and a half. So we should be able to go up to 23 or lower. It should detect something. Yep. It, I don't know if you can see the light. Okay. There's one more interesting thing. If you notice, between both the emitter and the reflector, there is a small notch, black plastic notch. If I touch it to the paper, as you can see, it reads higher loss. The reason is the light from this um, emitter are not coming back to the reflector. So it's kind of separating that. However, when I put my finger closer to it, I, the light lights up and you read lower values on the serial monitor. That's because shape of the finger, it creates a dent, and that is letting the right light reflect back. So what that means is shape or the kind of material that it is detecting also has impact on its sensing capabilities. For example, I have a convex surface here. If I come close to it, it's not detecting it. As you can see in the values in the window, it's pretty high values. However, I take a flat surface, it has a better performance. It's right up close. However, my finger right up close, it detects. So that's because the dent in your finger, that plastic um, separator creates, reflects the light. Essentially, this helps you understand how do you figure out what the sensor does, even though you don't have an understanding of the data sheet. If you look at the data sheet, typically it should come with the temperature range, it should come with the voltage range, so you don't connect higher or lower voltage for it to operate. It comes with the range. It should come with the range and an um, error tolerance. What may be expected. Again, these are not high powered, high spec sensors for industrial applications. I would assume you would get much more tighter tolerance devices for this purpose. All right. Thank you so much. As you can see, the code is exactly one line of setup. Setup is what runs only once when your robot starts. In this case, my Arduino board is my robot, and if you notice carefully, every time serial is written, um, the TX line lights up a little bit, demonstrating that it's, if you notice this one, it's kind of hard to see in this camera, but let's see if I turn off the light. Yes. So there is TX, that's what is sending your log or the readings back to your serial monitor. The line number 9 serial.println prints the value. That's it. So this piece of code is doing exactly two things. Read analog on the pin named A0, and you understand why A0 because that is what we connected the um, signal. If you notice it, A0 to A1 unlog in. So and it prints that. And we have a delay to make it more human observable. And let me actually remove the delay and show you what happens because that's not needed. So one line of setup, two lines of loop. That's it. That'll let you figure out what your sensor is doing. Okay, I need to upload it. Right there. It goes really fast and it becomes almost object detected, higher value, higher loss, object is not detected, object is detected again. So how does this work in a setup like this? So what you can notice is when there's lower value, it is on uh, an object or the surface that is reflecting higher amount. And now you can imagine with three sensors, these are three sensors which are going to be connected on, if you notice, RML, right, middle, left. So if right and left are following a bright surface and middle is following a black surface, typically you will have higher loss on the middle, lower loss on the left and right. As long as that condition is true, you can keep your robot moving. If that condition fails, depending on which side of the sensor is looking at the black surface, you can add a corrective action to left or right to correct that behavior. That's essentially how these line tracking robots work. Um, cool. Thank you all.